Good morning, students. Today we will continue with our chapter number 4, Atomic Structure and Chemical Bonding. Today we will study about electrovalent or ionic bond. We know that atoms of metallic elements have 1, 2 or 3 valence electrons can lose the electrons to atoms of the non-metallic elements which have 5, 6 or 7 electrons respectively in their outermost shell and thereby form an electrovalent compound. After the transfer of the electrons, both the combining atoms acquire the electronic configuration of the nearest inert gas. A metallic atom which loses electrons becomes positively charged and is known as cation, and a non-metallic atom which gains electrons becomes negatively charged and is known as an anion. So, we can define an ion as a charged particle which is formed due to the gain or the loss of one or more electrons by an atom. A metallic element whose one atom readily loses electrons to form a positively charged ion is electropositive element. Example, sodium very easily loses electrons and form sodium plus cation. A non-metallic element which can readily accept the electron to form a negatively charged ion is called an electronegative element. For example, chlorine, it can easily accept the electron and form the chloride ion. The cation and the anion, being oppositely charged, they attract each other and form a chemical bond. Since this chemical bond formation is due to the electrostatic force of attraction between the cation and the anion, so it is called the electrovalent or ionic bond. So we can define electrovalent bond as the chemical bond formed as a result of transfer of electrons from one atom of an element to one atom of another element is called the electrovalent bond. What is electrovalency? It can be defined as the number of electrons that an atom of an element loses or gains to form an electrovalent bond. Bonds formed between metals and non-metals are ionic or electrovalent. Why are the ionic compounds stable? Ionic compounds are formed by ions, but there exists a repulsive force between the like charges. So there are two types of forces present in the ionic compounds: electrostatic force between the opposite charges and the repulsive force between like charges, that is same charges. But the electrostatic force is more than the repulsive force, and that is why the ionic compounds are stable. Few examples of electrovalent compounds are sodium chloride, magnesium chloride, calcium oxide, etc. Cesium fluoride is the most ionic compound, as cesium has a maximum tendency to lose the electron, while fluorine has a maximum tendency to gain the electron. The features which are common to ionic bonding. First, metal atoms lose electrons to form the positive ions, that is cations. The non-metals gain electron to become negative ions, that is anions, except hydrogen. In both the cases, ions are formed which have a more stable electronic configuration, that is equal to the noble gas present to the ions. Ionic bonds are formed from the attraction between the oppositely charged ions. Now we will discuss the structures of some electrovalent compounds. Sodium chloride. The sodium atom has got 11 electrons which are arranged as 2, 8, 1. That means it has one extra electron to become stable. So sodium loses one electron and attains the configuration of the nearest noble gas, that is neon, whose configuration is 2, 8. So sodium ion is formed after losing one electron having the electronic configuration 2, 8. However, after giving up one electron, the sodium atom is no more electrically neutral. It has 11 protons in its nucleus but only 10 electrons revolving around it. Therefore, a net positive charge of +1 it attains, and it is called sodium ion and written as Na+. The electronic configuration of chlorine is 287. So it needs one electron to attain the stability. So it takes one electron given by sodium and forms the chloride ion having the electronic configuration 288, which is equal to the nearest noble gas argon, whose electronic configuration is 288. So chlorine, after losing one electron, forms the chloride ion. When an atom of sodium combines with an atom of chlorine, one atom is transferred from the sodium atom to the chlorine atom, resulting in the formation of sodium chloride. The cation Na+ and anion Cl- are attracted towards each other due to opposite electrical charges or Coulomb force existing between them and form the ionic compound. The electron dot symbol or the Lewis symbol. It is actually in the course of 10th, but a little introduction is done in the syllabus of 9th class. The Lewis gave a concept of dot diagram in which only valence electrons, that is the electrons in the last shell or the outermost shell, are shown by dots. This was introduced because orbit diagram is not so convenient, as electrons of only outermost orbits are taking part in the bond formation. So electron dot symbol it consists of the symbol of the atom surrounded by dots representing the outermost shell of electrons. So the electron dot symbol for the formation of sodium chloride is Na, you can see the dot, plus Cl with the 7 electrons in the outermost shell and showing the transfer of the electrons, forming Na plus Cl minus, or you can write it sodium chloride NaCl. We will discuss the structure of electrovalent compound magnesium chloride. Magnesium electronic configuration is 282. That is, it has 2 extra electrons in its outermost shell. If it loses these 2 electrons, it will attain the stable electronic configuration of neon. So it loses 2 electrons and forms magnesium ion Mg2 plus and gets the electronic configuration of 2,8. Chlorine, the electronic configuration of which is 287, it needs 1 electron. So the 2 electrons lost by magnesium will be taken by 2 chlorine atoms, and the 2 chloride ions we will get with the electronic configuration 288, which is equal to the electronic configuration of argon, the nearest stable element. The orbit structure of the formation of magnesium chloride molecule is as follows. The magnesium atom, having 2 electrons in the outermost shell, combines with 2 chlorine atoms and gives the 2 electrons to each chlorine atom, 1 electron to each of them, forming the compound magnesium with 2 positive and chlorine ions with negative charges. The electron dot structure for the formation of magnesium chloride is Mg with the 2 electrons, outermost electrons, chlorine atoms with the outermost 7 electrons, forming Mg2 plus 2 chloride ions. The next example of electrovalent compound is calcium oxide. Calcium's atomic number is 20, so the electronic configuration is 2882. So it has got 2 electrons in the outermost shell, which it gives out to form the calcium ion Ca2+, and attains electronic configuration 288, which is equal to the nearest noble gas argon. Oxygen has got the atomic number is 8 and the electronic configuration is 26, so it has 2 electrons less in the outermost shell, so it gains the 2 electrons given by calcium and forms oxide ion O2-, which has the electronic configuration 28, equal to the nearest inert gas neon, which has the electronic configuration 28. The orbit structure for the formation of calcium oxide is as follows. Calcium with the electronic configuration 2882 gives its 2 electrons to oxygen, whose electronic configuration is 26, forming calcium positive ion Ca2+ plus oxide ion O2-. Electron dot structure for the formation of calcium oxide is Ca 2 electrons which are in the outermost shell, oxygen with its 6 electrons. Calcium gives the electrons to oxygen, forming Ca2+ and O2-. What are reduction reactions? The reactions in which the electrons are gained or the gain of electrons takes place, they are called the reduction reactions. The oxidation reactions are the reactions in which the electrons are lost. So, in the formation of electrovalent bond, the electropositive atoms lose electron, or we can say the metals, they lose electron and undergo oxidation, while the electronegative atom, that is the non-metals, they gain electron and undergo reduction. So the reactions in which oxidation and reduction take place simultaneously are called the redox reactions. For example, the formation of sodium chloride. Sodium chloride is formed by the combination of sodium and chlorine. The reaction can be written as two half reactions. 2Na gives 2Na plus 2 electrons. Cl2 takes 2 electrons, giving 2Cl minus. So sodium, as it loses electrons, it undergoes oxidation. Chlorine, as it accepts or gains electrons, so it undergoes reduction. So the redox reaction for the formation of sodium chloride is 2Na plus Cl2 gives 2Na plus 2Cl minus. The properties of electrovalent compounds. Electrovalent compounds have strong electrostatic forces of attraction between the ions, which cannot be separated easily. So, on account of this fact, the electrovalent compounds are hard, brittle, crystalline solids. They are non-volatile. They have high boiling points and high melting points. They do not conduct electricity in the solid state, but They are good conductors of electricity in the aqueous state. Thank you.